Hello everyone, so today we're just going to be looking at some exam practice for location and spread. So this is all about pausing it, giving it a go, and then marking how you've done. Let's see how we go. So pause this, give it a go. Right, so using interpolation to get the interquartile range. So first we need to figure out how many we've got all together. And if I add all of the frequencies up, that comes to 80. So the interquartile range is going to be Q1. The lower quartile will happen at 80/4, which is 20, and Q3 will happen at 3/4 of the data, which is 60. So we want the 20th result and the 60th. Now we've got 5 there, we've got 5 and 10 makes 15 there, so plus 36 is 51 to there, 71 to there. So we want the Q3 and the Q1. Now when you find the interquartile range, it is Q3 take Q1, isn't it? So we're going to do this all in sort of one go on the calculator in a minute, but your working needs to look something like this. We're going to go for the upper quartile first of all. So we are at 9, hang on, we want 60th, don't we? So we are at the 51 plus 9 makes 60, so we are 9/20ths into this part here. Now this has been rounded to the nearest minute, so the boundaries are actually 49.5 and 59.5. Don't worry about calling it seconds, just go for a half. We can convert that later if we need to. So 9/20 times, what width is that? That is actually a width of 10, isn't it? Times 10, and we're going to be adding that to where this boundary starts, and that boundary starts at 49.5, and we're going to be taking from that Q1, which is the 20th, so we've got 15 to there, so that's 5 into the 36 that we've got, so 5/36. Again, it's a 10 wide thing, and we're going to be starting from 39.5 there. Whack that all into the calculator, should give you something looking like this. 118/9, press S to D on that, gives me 13.1 recurring. So to 3 significant figures, that would be 13.1 minutes. And don't worry about the fact that that's 1/10 of a minute, because we've put it in that, it means that, and it won't cost you any marks not to turn it into seconds. The mark scheme does not expect it. Right, on to the variance. So now you want to have a quick look in your formula booklet, bottom of page 3. This is the thing for the variance, isn't it? So we want one of these two here, and because we're wanting the sum of the x squareds, the one that we're looking for is the second one of those two that we had. So just to make that really clear, it was the sum of the x squareds, take away the sum of the numbers squared divided by n. So we have got two of those things right here. So that's going to be the sum of the x squared. That is that number there, 183040, and we're going to be taking away some of these 3740 squared divided by n, which is how many runners we've got in the whole thing, which is 80. Put that into your calculator, and that should give you 8,195. Only that seems quite a lot for the variance. Is there something I've overlooked? Oh, hang on. The variance is the summary date stuff all divided by n. So we need to then divide all of that by n. So we need to divide that by 80 once more. If I divide that by 80, I get 102.4375. And now the standard deviation is easy once you've got the variance. It is the square root of the variance which is let's go shift. Oh no, we don't need shifter, we just need to do the square root. Answer equals 10.12 or 10.1. And what's our 10.1 minutes, isn't it? So the variance was that, wasn't it? Okay, right. That's the end of the first question. Moving on in a moment. Right, here's your second question. Using calculator to find estimates for the mean and standard deviation first of all. Now you can do this using the table function in your scientific calculator if you've got it. Today, I've forgotten my one, so I'm going to practice without it, which is always good practice for us. But if you've got it in your calculator function, that's fine. So first things to do to estimate the mean. We want to estimate the mean, we want 12 times the midpoint of 11 to 13, which is 12, and the midpoint of 13 to 15, which is 14, so that's 14 times 14. Oh, that's interesting that that happens to have happened. And then we also want the midpoint of 15 to 17, which is 16, times that by how many we've got, which is 4, and divide by how many we've got altogether, which is 26 to 30. Whop that into the calculator and you should get 2 over 2 over 5, which is 13.46. Okay, so that means the mean we can say is 13.5. What are we looking at? Degrees Celsius. And then the standard deviation, I'm going to use standard deviation being the root of the sum of the squareds of our values divided by how many we've got, take the mean squared. I've already got the mean, so I just need to square that. But to get this, we're going to need, and we can whack it all in one go, we're going to need 12 times 12, aren't we, which is 144 squared, and we're going to need 14 times 14, which is 196, and we're going to need that squared, and we're going to hang on, no, we're not. We are going to need, let's do the sum of the things squared first of all. We're going to need that value squared. We need 12 of 12 squared, and we're going to need 14 of the 14 squared, and we're going to need 4 of the 16 squared, and that is what we're going to divide by how many we've got. So that's what we're going to divide by 30, giving us 183.2. So now the standard deviation is going to be the square root of 183.2 take 13.5 squared, because that was our mean. Only what I've done is I've used my answer from before, because remembering that 13.5 was a rounded up of 13.4, I think it was 6 recurring, something like that. Anyway, that's going to give you a fairly different answer if you were to just put 13.5 in there. So if you put all of that in there, you should get 1.36 minutes. Not minutes, is it? We're talking about degrees here. Degrees Celsius is our standard deviation for that one. Right, moving on to question B. The 10th percentile to the 90th percentile. So we want to take away the 90th percent, take the 10%. So we're looking at 0.9 times 30 being 27, and 0.1 times 30 being 3. So we want the third result, and we want the 27th. So the 27th is the first one to do. We've got 26 when we add those two together, so it's going to be the first result in there, or 1/4 of the way through this part here. So we're going to have 1/4 times, the width of that is 2, which we're going to be adding to the beginning of that class, and then we're going to be taking away, we want the third, so the third out of 12th, also 1/4 of the way through, that's also too wide, and we're going to be adding it to the beginning of that group was 11, and that should give you 4 degrees. And the final question here, estimate the number of days where the daily mean is more than one standard deviation greater than the mean. So first of all, we need to find out where that is. So one standard deviation greater than the mean is going to be 1.36, the above the mean being 13.5. So 13.5 plus 1.36 is 14.86. So we want to find out where that's going to come. So 14.86 is right up there. So how far through is that? Right, so slightly strange thing to think about here. So 13.8, so we're talking, the beginning of that group is at 13, so we're talking 1.86 out of 2. We've got 14 days within that. If we times that by that, you get 13.02. So you've got 0.98 of a day's worth of measurement in there on top of the 4 there. So the estimate, it's going to be closer, so that would be 4.98, wouldn't it? So that's going to be closer to 5 days. So 5 days would be our estimate. Here's our next question. So this one is all about using the formulae. They've already worked out a load of stuff for us. The data's coded, but let's not worry about that for the first part. So we've been told what they all add up to. We've been told how many of them there are. We've been told that what we need to know for the variance being that divided by n, isn't it? And if you remember, it does say your standard deviation is equal to, in the formula booklet, so we're just whacking that in to find the standard deviation. So the standard deviation will be 80.55 divided by 31, and the square root of that, which gives you 1.611. So to 3 significant figures, that would be 1.61. What are our units? This is talking about wind speed, isn't it? So 1.6. No, this is being coded, so there's no units that you need to give on it at that point. The other thing was the mean. Yeah, that's a bit easier to find actually anyway, isn't it? So the mean of the coded data, so the code's got that letter Z on it, so it's going to be Z bar. is going to be, what do they all add up to, divided by how many of them there are. 106 over 31. 106 divided by 31 is 3.419, so that's 3.42 fig. Right, working out the mean and standard deviation of the daily mean wind speed. So we've got to decode what that is. As far as the mean is concerned, both of these things are going to have an effect. The last thing that's our original data has had 3 taken away and then divided by 2. So for the mean, we're going to need to multiply it by 2. I'm going to keep my original number here so that I don't times it by 2, and then reverse taking 3 by adding 3. So in fact I've got the old number there. I'm just going to press times 2 and add 3 and see what that gives me, which is 9.84 to 3 significant figures knots. And then standard deviation is actually easier, because what they're testing here is that you remember that it's only the dividing by 2 that has made all of the data much closer together. So we've got to make it further apart by multiplying it by 2. But the taking 3 has just made it all smaller by 3. It hasn't affected how spread out it is. So all we need to do is go back to our standard deviation and times that by 2. Now, to make sure that you get the accuracy right, I hadn't written down what that final answer was, so I'm just going to put that calculation in there again, because it's very, very annoying to lose 1 mark when there's only 2 marks for this anyway by an inaccuracy like that. So we need to multiply all of that by 2. Oh, watch out, got the square root carrying it on there. So times that by 2 gives me 3.223, so that would be 3.22 knots. Great. Right, one more big question to go now. It's in 2 parts, so I'll just give you the first part about the owlets. You have to wait for the giant ibises. So we're into rare birds territory, folks. Right, starting off, the mean is pretty simple, isn't it? The mean is going to be how many we've got all together divided by how many owlets we've got, which is 20. Which should have given you 15.8 centimeters, that's going to be. And then the standard deviation is going to be what have they given us? They've given us the mean, right? Yeah, so we're going for the sum of the squareds divided by how many there are, take away the mean squared. So what that looks like is 5078 divided by 20, take 316 squared, and that should give you, oh, mass error, what have I done wrong here? Oh, hang on, it's not the mean is not 316, is it? That's the sum of it. That needs to be over 20, so that should be 15.8 squared. So if I press SC, that, oh, okay, go all the way through that again, gives you that, which is 2.06 to 3 significant figures. That's centimeters, isn't it? Right, now one more bird was caught. It had a wingspan of 13 centimeters. Without doing any further calculation, how will this affect the mean wingspan? Well, it's less than the mean wingspan, so it's going to bring it down. It will reduce the mean wingspan. That's all that needs. Now, there's a few of those sorts of 1 mark questions in there, and it's generally just write down a bit of common sense about what it means. That's all they're looking for. moving on from the owlets, we've now got 20 giant ibises, also caught for ringing. That just means marking them, doesn't it? Putting a little ring around their foot so they know who they are and where they're going from. Give it a go. So it's been coded, and we've got this detail. We need to know the mean and standard deviation of the actual wing speeds. Before we do that, we just need to work out the mean and standard deviation of the coded data. So the mean of Z is going to be 104, because that's all of it, divided by the 20 that are there, which gives us 52. Now the mean of the actual things are going to be, it's had 5 taken away, then divided by 10, so we just need to reverse that process. So if I call the mean of the actual ibis x bar, that's going to be 52 times 10 and then add 5, which is 525. Now the standard deviation, make sure I do this right this time, is going to be the square root of 1.8 divided by how many there are, which is 20, isn't it? So the square root of, and actually I'm not really bothered about what that is. All I need to know is for the coded data, which is standard deviation of x, is going to be that, not divided by 10, because that's made it less spread out. We need to spread it out some more by timesing that by 10. So I'm going to chuck that into the calculator just like that. 1.8 over 20 times 10. And that's giving me 0.9486. That's 0.949. And what is it? Centimetres. Yep, we should have centimetres for both of those. And I've just checked my answers and I've made a couple of whoppers here, I'm afraid, folks. So 104 divided by 20, I'm sure some of you realise that should have been 5.2. If I did 5.2 times 10, that would be 52 plus 5, actually makes 57 centimetres. And tell you what, a giant ibis, they're big birds, but that would be some giant if they had wingspans of over 5 meters, wouldn't it? That's quite something. Anyway, sorry about that. And also I made another mistake on here, because I if you look back, it's probably going over there. This is wrong. If you do the square root of square root of 1.8 over 10, you get that. If you times that by 10, you get 3 over 2. Oh, that's because I put the wrong number in there. Start again. So never rush, folks. I'm rushing. That's my problem. 1.8 over 20 equals 3/10 times 3/10 by 10, and you do get 3. So I should have had 3 centimeters there. So a word to the wise: be very careful with what you're doing with a calculator. One is, be careful with when you're dealing with a calculator, but also make sure you use the calculator for simple divisions. Check it in your head as well, but don't just rely on it. Okay, folks, hope you got on well with that. Cheerio.